Okay, thank you very much, Barry. Is there a way for the sound to be less loud? Or this is just how loud it's going to be? Okay, thank you. All right, thank you very much for the introduction, Terry. Today I'll be presenting on one of the chapters from my dissertation titled Farmer Socio-Technical Imaginaries for Canadian Agri-Food Futures. And thank you also for the land acknowledgement. I also want to begin by positioning myself with gratitude for living, playing, eating on the traditional, ancestral, and unceded territories of the Musqueam, Tsleil-Waututh, and Squamish peoples. And I'm also influenced and grateful for the lands and people who raised me on the other side of so-called Canada, and acknowledge that I come to this work about food systems with a great deal of privilege and not a lot of lived experience or success of keeping plants alive. So I have about 20 minutes here with you today to talk about a chapter that I'm quite excited about, but brings together several different ideas. And my goal is to convince you that including this word of jargon in my title was essential and actually part of what makes this topic exciting. And at the bottom of the screen, you'll see a progress bar, so you can see how far we're getting to the edge. So before we get too far in, I know that lots of folks in our department engage with food systems. Lots of people talk about technology, but I want to make sure we're starting on the same page. And so I'll be speaking about digital technologies in agriculture. Sometimes that's referred to as precision agriculture, smart farming, or digital agriculture. But the reality is that many and most farms on Canada use digital technologies, not only in their daily lives to check the weather, post on social media, but also to help with their farming systems and operational decisions. And in this umbrella category of digital agricultural technologies, we include any tools, systems, devices, or resources that are used on the farm operations to generate, store, or process data. And this includes some things that have been around for many decades now. Early adoptions of digital technology in agriculture had to do with integrations of GPS into tractors to assist them to drive precisely straight across the field and never overlap any of the field that they've already passed. And more recent innovations like using the cloud or AI in food and highly sophisticated robotics. These technologies are quite contentious. They're discussed in quite polarizing ways in public and academic discourse. Many have a sense of optimism about their potential to grow more food on less land with fewer environmental consequences. Some of the proponents beyond the developers of the technology themselves, of course, are banks and other civil society groups like the World Economic Forums. But there's also a very healthy and growing counter movement that is highly critical of these technologies and use them as antithetical to the vision of sustainable and just food systems that they are proposing. If we look at how these technologies are discussed by their developers, many of the familiar big food names that we know, like Bayer and Monsanto or John Deere, you see words like profitability, productivity, efficiency, sustainability, connectivity, and better decisions as part of the promises. And beyond these buzzwords, they're creating or knitting a view of a future that they aim to contribute to, a future of what the food system could and should look like. And this promotional image I have included on the slide, I like because it brings together many of the tools. It helps us visualize what a digital farm looks like from the perspective of these corporate players. But it's also quite ominous to me. This rosy picture can be a prompt for us to think about who's not there and what are the consequences of imposing this future on the food system. So we could think of this not as visions necessarily, but as prescriptions for agri-food futures, where those in power over the development and governance of these tools determine not only what data is collected, why, how it's used, the functions of the technology, but also what systems of crop production and labor configurations that can prevail in the future. And I was curious, are farmers buying these narratives? Adoption rates are rising, but are they convinced of these promises? Do these tools take part in their visions of what the future could and should look like? And so I was drawn to the concept of socio-technical imaginaries to think through some of these systems, these ways of being. And socio-technical imaginaries is a concept that comes from the science and technology studies literature from Jasanoff and Kim, who introduced the concept first in 2009 and then expanded upon it in a really seminal book called Dreamscapes. So its socio-technical imaginaries are collectively held, institutionally stabilized, and publicly performed visions of desirable or undesirable futures, animated by shared understandings of forms of life and social order, attainable through and supportive of advances in science and technology. This concept is rooted in ideas of co-production, which are central to science and technology studies that view social systems and technological systems as inextricably linked and view discursive and material implications as necessarily a part of those socio-technological systems. And these imaginaries or concepts live in the world. They are contested and move through phases of what they call origins, systems of embedding, systems of resistance, and then extension, where a socio-technical imaginary can emerge from one small group. But then when we get to extension, that's when it's starting to be picked up by other groups or actors beyond that first group or across continents or different parts of the world or across time. So why socio-technical imaginaries? It's not a perfect frame, certainly, and there are many to choose from, but I have a few reasons why I thought it was worth exploring further. The first is that it makes good use of the co-production of socio and technical systems, which feel very central to discussing the future of the food system for me. It also incorporates ideational, institutional, and material implications of science and technology. It is able to hold multiple truths. Things can be both good and bad, not either or, but both. And it allows us to look at how things are contested and changing over time and space. It includes a normative account of the past, present, and future. So how we think about the future doesn't only impact, or it's not just an exercise of trying to predict how things will be, but it has impacts on how we live in the present and what kinds of decisions we make for the food system today. And then finally, it provides us a lens to look at power. So who gets to decide what the dominant view is? How do imaginaries interact with discursive power, for example? And so I had a really great opportunity to take this curiosity I had about the concept and the ideas of farmers to work with Hannah Whitman's grant with a professor at the University of Guelph, Evan Fraser, and his PhD candidate, Emily Duncan, to test the set scale. So we were able to run a survey of 1,000 farmers in Canada, which is really exciting, and something that would not have been possible without the funding of the grant and us hiring a market research firm that specializes in agriculture. And we asked them 60 questions. It took them a long time to get through, but don't worry, they were compensated. And we asked them about their attitudinal view or attitudinal variables, demographic variables, and really interesting ideas of what affordances of data and digital technologies are relevant to them. We asked them what they adopt and why, and then two main variables that I'll talk about today in trying to understand the socio-technical futures that these farmers espouse. So a little bit more about the study design. The inclusion criteria was that they would be farmers. This was with the census definition of owner-operators. So this is a narrow definition of farmer. There are people who are farmers who might not be managing a farm necessarily. So this does not include other laborers that are not managing the farm. They had to live in Canada. They did not have to be Canadian citizens, and they had to be over 18 years of age. We had quotas for region. We had 21 quotas divided across the provinces with no possibility to include the territories with this market research firm. And we also had quotas for the 11 farm types that are identified by the Canadian Census for Agriculture. This is a mixed method study, which is a little bit outside of my comfort zone. It's my first, but was part of what made the project so exciting to me. So I'll be presenting to you some qualitative analysis that we did with coding of the text responses in the survey, and then a little bit of quantitative work, starting in the shallower end of word frequency counts, and then a little bit of descriptive statistics and inferential statistics that we ran on the survey results. The research questions and the rest of the design come around my conceptualization of socio-technical imaginaries. So the three main ideas from the definition that you saw before are here on the screen. But This includes two things for me. First, what does the future look like? What is the content of the future? And then second, is the future that they view as most likely, is it desirable, is it undesirable, or neutral? And so for the contents of the future or the imaginary, we develop a scale or measure for socio-technical future scenarios that we tested in this survey. And then we also used an established scale from psychology research and established survey methodology about affect and affective images. And these concepts also were the source of our research questions. And so the main question became, what socio-technical imaginaries about digital technologies in agriculture do farmers in Canada espouse? And to answer that, we needed to know what future scenarios do farmers view as most likely, and what affective images do digital technologies in agriculture evoke for farmers. So, and then of course, we had the great wealth of having this data, those very large sample size. And so we also wanted to know, how do these vary depending on individuals' characteristics? So I need to take you back to a little bit of theory, and then we'll get just into the juicy data. So we're using an existing scale, so I need to define to you what affect is. So affect can be understood as an abstract, non-conscious experience of feels. This is kind of like the gut feels, our first impression. The most common scale in psychology research is the positive and negative affect schedule. But we were looking at affect in another way that's commonly used, as just affect as influence, intensity, and impact of a stimuli, of an idea or something that people are interacting with, so that you can see how people judge something as good or bad on these quick evaluative judgments. Affective images recur rapidly and automatically in this approach. This is what's assumed. And they tend to elicit some unfiltered and relatively context-free and spontaneous responses, which is an interesting thing to talk about as a social constructivist, but we'll leave it there for now. And the images are not limited to a visual. Affective images include sights, sounds, smells, ideas, and words. This method allows us to collect those ideas or sounds or words from participants and see which carry the greatest impact on how people feel, which make people feel very positively or very negatively. And in the survey, we collected this data by asking them about a word association. This is the common way to collect affective images in survey research. So the very first question in the survey was, after the introduction and the ethics, what are the first three words that come to mind when you think about digital technologies in agriculture? And then the next thing to populate was for them to establish or report on how these words made them feel on a scale of 5. From 1 being extremely negative and 5 being extremely positive. So that's the affect portion of our construct. The socio-technical futures, this is not an established scale, but we divided up 10 key ideas from the literature and past research experience of mine and of the research collaborators at the University of Guelph as the key things that are being discussed or viewed as important for farmers in Canada. Those include the decline of rural communities in Canada, relationships between robots and labor, the divide amongst farmers between high-tech and low-tech farms. And for each of these, they appeared on a scale of 1 to 10. These images are to help you to conceptualize what this would look like, but we didn't use any images in the survey design. So they had to place their most likely future on a scale of 1 to 10 with no option to be neutral. So they had to decide if it would be more likely to be negative or more likely to be positive, with sentences on either side or phrases on either side to help them imagine what would be a negative scenario and a positive scenario. All right, so now we've made it to results. I can talk a little bit more about the sample and the question and answer period, but we collected the following demographic information. So you can see that our sample is mostly men. There is a majority of men in Canada in terms of farming, but that number is about 70. So this is the one socio-demographic variable that is the least representative. But our mean and median age are bang on. Years of farming, we measured that as well in terms of their own input of age. We measured whether they were the first generation or second or more generation of farming in their family, their formal education. Their ethnicity is also a little bit biased towards white and European settlers. But we Yeah, so we can talk a little bit more about that. And then we also included the provinces. Our quotas were successful in representing the different regions where farmers live. And we included an attitudinal scale for political ideology. Thank you. Okay, so first we'll present the results of the affective imagery analysis. So this was a bunch of words. Each respondent entered 3 word associations. We removed one set of responses for being irrelevant, but that left us with 2,997 words to analyze. And the first thing I did was bring them all together to look at them at a word frequency cloud in NVivo. And then we also looked at the count, the frequency of entry of each of these words. There were 750 original words entered. And you can see that there's only a handful that are above 50 times entered that are on the screen. Then we looked at a content and thematic coding that was inductive. So these are labels that I created to describe what data was most frequently entered. So the largest categories are tools and technologies. So the majority, over 50%, were word associations that were literal technologies that fit digital technologies in agriculture as a category. And then the second most common is positive evaluative words, adjectives like amazing, accurate. The other categories included negative evaluations, so that was the next most frequent, but much less frequent than the first 2. Words about data, words about knowledge, farm operations, and then specific products and companies that I separated from tools and technologies. The majority of these responses were overwhelmingly positive. So the mean affect on a scale of 1 to 5 was 4.1, with 77% of the word associations being labeled by respondents as either positive or extremely positive. If we separate out the affects labeled by respondents, you can see that there are some differences in what words are most frequently entered. And so in the positive with the green, the neutral with the yellow, the most frequently entered words are nouns, descriptors of what these technologies are. So the biggest one in positive is GPS, followed by auto steer, and so on. In neutral, similar thing. Variable rate is an application of digital agricultural technologies. But when we looked at only the ones that were labeled by farmers as extremely or somewhat negative, then we see almost all adjectives, things like expensive, complicated, time low, or time, or oversold, more critical words. Okay, so now we'll move to the futures results. This is my favorite figure, the favorite chart I've ever made, but there's a lot going on here, so I'll walk you through it. Each of these bars is one of the 10 scenarios that we asked farmers about. They each had to list the most likely scenario for the future on a scale of 1 to 10. And then the percentages are the percentage of respondents that answered in each of these bins of 1 to 10. So the 6 most positive kind of group together. And most of these are also the promises that are made by the developers of these technologies. Is it going to help food security? The majority, like not much of a majority, but 55 think yes. Is it going to help solve environmental problems? There's 59% think it's more likely to be yes than no. But we've got 4 really interesting ones that are a majority of people view as most likely to be negative. And those are contributing to the further decline of rural communities, resulting in greater power accumulated by corporations at the expense of farmers, access to land being harder to acquire, and it creating a greater divide between high-tech and low-tech farms, where only 38% of respondents thought that these technologies were likely to benefit all farmers. The statements are all positively correlated and tightly associated in the scale. And we ran a series of multiple linear regressions on these scales, both as sums, so adding up all 10, and individually. And I only want to highlight one that I found really interesting, is that the 4 that were standing out as most negative are strongly positively correlated with age. So older farmers are more likely to view these as more positive. Younger farmers are more likely to view these as more negative. So to sum up, the affect, the first impression, the gut response is pretty positive. When we ask them about this category, they're able to think of many words that fit within, many technologies that they view as part of this category, which helps us know what is most salient, what is most quintessential digital ag. And there's no significant differences across groups. It's all very clumped towards the positive. But when we look at the socio-technical future scales, there's a lot more variety. 4 scenarios stand out as particularly negative, and those have a lot to do with systems of power in the food system. And there's a significant linear regression result with age. And we view these as being collectively held. These imaginaries don't represent all farmers in Canada, but there are many things that we do have that are representative. It risks making us think that everyone feels this way, but the minorities also have powerful views, so we can talk about who's in those extreme categories. And why does the imaginary matter? These farmers are in systems of power. These are the people on a farm that get to decide what tools they use and don't use. They have power over the operation, power over their laborers, and so it does matter what they think the future will look like and what they think the future should look like. And before I end, I want to say that this was a really interesting study to run as someone who's trained in qualitative methods primarily, and an interesting way to think about something like affect in a quantitative, large-scale way. And so the affective literature in which I engage talks a lot about how affect is relational, it is practice-oriented, and that's a limitation that we don't get into. But the flip side is that we get to hear from 1,000 farmers. I could not interview 1,000 farmers in my PhD. And so that's a really interesting thing that this offers. And there's only one other mixed methods study for socio-technical imaginaries. And so this was an exciting way to test this out. Their survey was a bit smaller. It was 100 respondents, or 150 respondents in the Baltic region. And so it's a pretty exciting opportunity to think more deeply about what this concept can do for science and technology studies and food studies. So thank you very much for your attention. There are a lot of people who helped me get here, including the collaborators at the University of Guelph, my lovely, lovely committee, who's all here today, and my peers. So thank you for the statistical assistance and the kind feedback throughout. Okay, Nigel.
Incredible.
Oh, thanks.
I'm curious about
Mm-hmm.
Are you surprised by that whole bias of business and specifically now and I wouldn't be that
Mm-hmm. Mm-hmm.
I'm wondering if that
Great. Thank you, Nigel. The question for Zoom is a methods question on the affective image analysis, the strengths and limitations, and if anything surprised me. So I want to take you back. Can I get to the other? As I'm trying to find my cursor, I will begin my answer. Usually this scale is used with public. And so there's one I really like that looked at the influence of fracking on public. So what their associations were. There's usually a lot more variety in what people think and a lot more variety in the affective responses. Here, a large majority were positive and almost all of them were relevant. Usually you exclude like 15 to 20% of the responses because one of the ones that is in the article is Battlestar Galactica was a fracking association and they were like, maybe this one we don't use. But with the exception of one, which was just a little bit cheeky of a response, it wasn't irrelevant, but we removed it. Everything else made sense. And GPS makes sense for farmers because this is the digital technology that's been around for the longest in impacting farm machinery. So that one wasn't surprising. But the fact that they clumped so much I was hoping for more distribution. And so I'm really glad that we asked it in a couple different ways. So we had a lot more distribution in the socio-technical future scenarios, which allowed me to do different kinds of analysis. So that part surprised me. But yeah, I'll leave it there. The literal responses, it's not usually how it goes, but it made sense for this sample. These farmers are very aware of digital technologies in agriculture. Yes.
Are you more asking people to think about ideas and then something fit? Or are they designed in a way that people think like bring themselves in their own shoes and think, who would I be? What would it look like for me to be on my car?
Great, thank you. Another methods question from the room for the sake of Zoom about how this question was meant to be interpreted. And so these two demographic or dependent variables were interesting in their contrast. So the affect is the very quick, like gut response. The future scenarios came about midway through the survey. They'd already talked about these tools in a few different ways, and we put it there on purpose because we're asking them to think a little bit more deliberatively about what the future is most likely to look like generally. So the question we gave them was looking 30 years into the future, where do you write the likelihood of the following impacts of digital agricultural technologies? So it's not necessarily limited to their farm. We did have some respondents that are in their 80s. So hopefully by then they've retired, they deserve it. So then maybe they're thinking about a food system that's after they're done, but maybe their children or the successors on the farm are still farming. But a lot of these have more systems impacts than some of the other attitudinal scales that are common when talking about adoption. Like, does this tool help you save time? Do you think it helps be more profitable? Milind. And then
you premise the talk something dystopic about it.
Yeah.
And then you end up with essentially almost uniformly accepted positive negative. So why is that happening? Why isn't the instinct to see this as sort of fallen, sort of dystopian future not being reflected in the sort of daily lives?
Thank you. So the question was about, I said in the beginning that I worried about a bit of a dystopic future, and I included the rosy picture almost like satirically, but the responses are primarily positive. So from respondents, both in terms of the affect and then in terms of the majority thinking that the most positive scenario is most likely for those 6. That was a bit surprising to me. When I ran interviews for my master's, people were ready to talk to me at length about how terrible these tools were. But I think that that's a smaller group. There certainly were people in the negatives, and these are tightly associated. So someone who thought the future for robots was likely to be negative also thought it was likely to be negative for corporate power. But the sample is largely highly capitalized commodity farmers that are using these tools because they're helping them. And so that's imaginary makes sense when you think about who's in it. And I think it would be interesting as a qualitative researcher to be able to talk to those people in the red bars. But that's a trade-off that I can't do. I don't know who they are. So. Yeah.
There's something about technology which might elicit or immediate positive reaction.
I'm just thinking there's some examples where 90% of the word associations are negative.
Yeah, usually you see something different.
You would expect that.
I think it would be similar. Yeah, and part of why we put this halfway through is because they had a lot of time. Like, a lot of the questions required a fair bit of thinking. Like, they weren't the gut response. They were like, do you think this on average, are the risks likely to outweigh the benefits or something like that? So, but I want to respect our next presenter's time as well. So thank you so much for your questions. I'd be happy to chat more.
Looking at electric vehicles in their various applications, this particular talk is looking at the sort of heterogeneity in costs across different individuals, archetypes, if you will, in Canada, and what implications that has for the diffusion of electric vehicles. Thank you. Did I say he works with Amanda too? Did I mention you? Yeah. Okay. Just making sure.
So when I said Melinda do the talk, you actually did my first slide for me, so thank you. Good afternoon, everybody. My name is Bassam Javed. It's really nice to be back on campus again. It's been probably about 3 years, and I've been here 3 times, so it's very nostalgic to be back and also to take a day off work. It's wonderful. So just to get started, I'll do a quick outline of my PhD research before jumping into the study, some context, methods, results, and then at the end I'll wrap it up with a bit about policy implications of the results. So my PhD research broadly seeks to understand what public policies can help to advance clean and affordable transportation, particularly in Canada. So I have a study that looks at small to medium-sized enterprise fleets. I have a study that looks at industrial policy in China, especially around e-bikes and low-speed electric vehicles. The study that I'm looking at today that I'll talk to you about is about passenger vehicles. So very much focused on the consumer. So things about like, how much does it actually cost a Canadian to purchase an electric vehicle and to own and operate it, basically. So that's sort of the study for today. So just to sort of set up a little bit of a context, transportation accounts for about a quarter of emissions in Canada, and it's actually forecasted to rise to close to about a third in the coming years. So in response to this, the government of Canada has kind of taken this, they call it a whole of government approach, which involves several ministers and their respective ministries, to basically set up this thing called a zero emissions vehicle mandate, which basically says that 100% of cars and passenger trucks by the year 2035 have to be zero emissions vehicles, or ZEVs. Now, in the context of Canada, that's basically electric vehicles. Hydrogen is sort of a bit challenging for the passenger vehicle market, particularly in Canada. Now, although EV sales in Canada are rising, as they are elsewhere, they largely seem to be taken up by early adopters. Although there is some evidence in the past couple of years that this is changing a little bit more into the mainstream market, but still it's sort of still in the early adopter segment. So really the hook here is achieving the 2035 mandate, which will impact all of us living in Canada in 2035, will be moving beyond the early adopters and actually going towards the typical household, actually going to the mainstream typical household. And so really what it comes down to from a consumer perspective is it's all about costs. How much is it actually going to cost us to go electric? And so this is where I set up my research questions. The first one basically is how do these costs and benefits of electric vehicles, or EVs, vary across different geographic regions and different household types in Canada? And then following from the gaps and the disparities that are identified in that first question, the second research question that I pose is, what additional policies do we need to enable rapid and equitable electric transportation for a range of those households across Canada? Now, just to talk about my method, I use this thing called a total cost of ownership, or a TCO, which is basically a method for estimating quantitatively how much a vehicle costs a consumer over the lifetime that they own and operate it. So I have the schematic figure on the right-hand side. And so I'll take about a half a minute to sort of walk through this, because this is sort of a pivotal piece of explain the rest of the presentation. So on the y-axis is basically we're looking at the difference in cost between a internal combustion engine vehicle, or an ICE or a gasoline car. I'll sort of use those terms interchangeably. So the difference in the value between a gas car and an electric car. And right now, gasoline cars are cheaper, meaning EVs are more expensive, but EVs are cheaper to operate. So the more that you drive it, it's actually better for the economics of your EV. And so we can actually kind of follow this on the schematic figures that, at the zero line on the y-axis, when you just buy it, you're sort of in the negative. That gap is really, really big between a gasoline car and an EV. But sort of the more you drive it, the more you take advantage of the fact that it's cheaper to drive an EV. And eventually you actually reach this point where it intersects the x-axis, the amount that you drive it on a daily basis, where it actually becomes, that gap becomes zero. So we call this the break-even point in the vehicle kilometers traveled, or the VKT. VKT is basically just sort of a fancy way of saying how much you drive on a daily basis. Now, the utility of this particular tool is that it actually allows us to kind of compare different scenarios, right? So in the green line there, say the break-even point is about 75 kilometers per day. For another consumer, or for another Canadian, it could be 200 kilometers per day or 110 kilometers per day. So we can actually kind of compare these different scenarios based on this, this simple method called the total cost of ownership, or the TCO. So what about all of these scenarios then? So in Canada, so we expect the Canadian households to vary geographically as well as in behavior. So we kind of set it up in these two different buckets. So geographically or spatially, all of the provinces and territories kind of vary in terms of electricity price, ranging all the way to tax rate, as well as temperature as well, the average temperature of a province or territory. But then behaviorally, they also vary as well. So in terms of the type of dwelling that one could live in, the type of vehicle that you purchase, the decision that you take in order to actually purchase a vehicle, or the perspective that you have, and I'll sort of get to that interesting point later, as well as how much you actually travel. So in order to kind of capture all of this variation, which is a lot, what I actually did is to basically layer archetypes onto this. And so I'll kind of walk through some of these archetypes. So the typical household, which is basically all of the provinces and territories, we expect there to be variation in all of the parameters that I've listed in the middle column there. Then the next archetype that I sort of set up is an urban household versus a suburban household. And this is sort of getting at the differences that people have in charging their electric car. So a suburban household, say, for example, a single family home, very easy to install something in your garage to make your charging go a little bit faster than a wall plug. Whereas an urban household, say somebody lives in an apartment or a condo building, or in a Vancouver strata, which doesn't let you sort of upgrade your electrical infrastructure, it's much harder to do that sort of private charging, as I call it. And so these sort of people sort of rely a lot more on public charging infrastructure. The next one I have is budget constrained consumer versus wealthy consumer. This is sort of the difference between a person who is constrained by the amount that they can pay per month for car payments or in a lump sum, versus a wealthy consumer, someone who's just able to just purchase whatever vehicle they want, regardless of what it is, whether it's small or big or luxury or not. And then the last one there is comparing a typical household to a super user. So a super user is an entity such as, say, Uber or a taxi company or logistics, some business that basically drives a lot every day. And so as you saw in the previous graph, driving an EV more makes it better for the economics of that car. And so the super user is kind of comparing the typical household to that. So what sort of variation do we actually see across Canada? Well, so over here, I have all of the provinces and territories listed in this bar graph here. The darker bars on the left-hand side under each of the jurisdictions is basically referencing to the actual daily distance that is driven in that particular jurisdiction, according to Statistics Canada data. Whereas the lighter shaded blue graph bar on the right-hand side is that VKT, or the amount that would be required for a gasoline car to equal in value to the electric car. And so what we actually see is that variation is really drastically different across Canada. So for example, in Quebec, the amount that the typical household drives is actually not very far off from what would be required for that gap to be small between a gas car and an electric one. But in Nunavut, it's actually quite different. The amount that you would be required to drive is actually 10 times more than the typical household would actually drive in Nunavut. So there's actually quite a bit of a stark variation, as we can see across Canada. We can also look at it from a different perspective in terms of costs as well. So this is a heat map of the provinces and territories. The darker color, so for example, Quebec there, it only requires over a 7-year lifetime, would only be about, say, $2,500 more in this particular case that I've run, versus, say, Nunavut on the other side, which is costing, I think, about $18,000 more to own that vehicle for 7 years. So there's a lot of variation. So the next question to kind of ask then is, where does all of this variation come from in Canada? I mean, it's quite a bit, and then how does that actually happen? So what I've basically done then is this particular bar graph here. So I've taken Quebec, which we saw in the previous slide is the most favorable jurisdiction for owning an EV. And I've actually compared the rest of the provinces and territories to Quebec as that reference point. So to walk through an example, let's take the case of Alberta, for example, all the way on the second from the left. In Alberta, because of the rebate value, the purchase rebate value being less than what it is in Quebec, it would actually take about 20 to 25 kilometers more distance to be driven daily in order for an EV to equal a gas car. versus say the value of the tax rate, which is actually less in Alberta. So going to buy a car in Alberta, you actually pay less money on the taxes, and so that actually shows up as a positive. So it goes the other way, say an extra, less by 5 kilometers or so. So each of those boxes that are shaded, which represent the parameters along the bottom, the spatially varied parameters along the bottom, kind of add up in terms of the negatives and the positives. So you can see that there's quite a bit of variation across Canada. So there's a couple of notes that I wanted to make here. One is that aside from the Northwest Territories and Nunavut, where the electricity price, that very high electricity price in these two territories contributes to the difference that's seen there. The difference is largely driven by the value of the rebates. So Quebec having the highest rebate amount and the rest of the provinces having varying levels from that. As well, secondarily is the electricity costs. So these are sort of the two parameters that kind of make up for the biggest amount of variation. The other thing I wanted to note, this is sort of a funny thing that happens in the graph, is that the dots are actually the difference between the jurisdiction and Quebec in terms of its totality. And you may notice astutely that the dots don't necessarily add up to the pluses and minuses. And this is because the boxes are just representing sort of the scenario individually. So either the electricity price or the gas price individually, whereas the dots are all of those effects happening together. So there's a bit of interaction happening within the model. So sort of changing gears then to how things shape up behaviorally in terms of how things may vary for a different type of consumer in terms of how much they can spend. So the first thing I look at is a wealthy consumer. So let's say, for example, I'm a wealthy consumer, which means that I'm not constrained by price. So I can buy whatever vehicle I want, right? So I have an option. So I go to the dealership and I want to purchase a subcompact SUV. So I can get one of these two vehicles. So I can either get the one on the left-hand side, which is a Hyundai Kona, the gasoline version, or I can get the Hyundai Kona electric, the blue one on the right-hand side, which costs about $20,000 more. For me, it doesn't matter. I'm a wealthy consumer. I want a subcompact SUV, so I don't really care if it's gasoline or electric. I just want that particular one. But of course, the electric one costs a bit more. So for this kind of consumer, how did the economics kind of play out? So this is what the break-even VKTs or the daily distances that would be required kind of look like. So if we just focus first on the yellow line, which is the subcompact SUV, the Hyundai Kona, I would have to drive about 75 kilometers per day. And then if we compare that to a couple of different types of vehicles, so let's say the luxury compact SUV, so getting a little bit bigger and then going luxury, it's actually not that much different. It would maybe require me to drive another maybe 10 to 15 kilometers per day more in order for my gasoline car, my EV to equal in value to the gasoline car. But what's interesting, you'll note, is that the gray line, which is the mid-size sedan, so here I compared a Tesla Model 3 to Toyota Camry, right? That line is way out there, which means that I'd have to drive close to 250 kilometers per day from my Tesla Model 3 to equal in value to a Toyota Camry. Now, the reason for this is that we still see that there's quite a bit of disparity in certain segments of the vehicle market. So not all EVs are created equal, basically. So for the subcompact SUV, it's quite a bit closer to where Canadians across Canada are driving. Whereas for the mid-size sedan, which you actually expect being a smaller car for it to be better, but it's actually worse. And so basically what we're finding is that because of the availability of very fuel efficient gasoline mid-size sedans, it actually makes similar EVs unfavorable. So the key takeaway from that is basically that not all EVs are created equal. Now, what about for the other type of consumer, which is budget constrained, that's definitely me, which is having a fixed amount of car payments per month, right? How does this kind of look like for them? So let's say, for example, I go to the dealership again and I have a budget and I can either get a Hyundai Kona EV, or I can use the same amount of money and I get enticed to buying something a little bit bigger in a gasoline car. So that's, for example, this one over here, the Toyota RAV4, a bigger car, same amount of value as a Hyundai Kona EV. So what does that kind of look like? This is sort of a trivial result, but I wanted to just use this as a step to jump to the next one. So of course, because the value is the same and the EV is cheaper, then the economics are immediately favorable for the EV. Now, this seems like a trivial result, like I said, but if we look at this in the context of this next one here, and I'll sort of walk through this with an example as well, what happens if I switch to certain types of EVs? So again, I'm going back to the dealership for the third time here. So let's say I'm in the market for a luxury compact SUV, right? And If I'm comparing a gasoline version to an electric version, okay, perfect, you can see my cursor, I would actually pay $7,000 more over the course of the lifetime of that vehicle for the electric version of the luxury compact SUV. However, if I was to be feeling like I would, if I was to consider a smaller car in an electric, so let's say I were to consider the subcompact SUV in an electric, I would actually be saving $53,000 over the lifetime of that vehicle. Not unreasonable. Yes, of course, I'm losing the luxury component of the vehicle and I'm going a little bit smaller, but it's not that much different than what I intended to buy. So this sort of takeaway from here is that there's certain types of EVs that we can switch to that actually could result in a large cost savings. And that actually has an implication for policymakers as well, which we'll jump to on the last slide. Changing gears for a little bit to look at urban households versus suburban households. Urban households, remember, being ones that have difficulty in accessing private charging, so they're relying a lot more on public charging infrastructure, versus suburban households, which can sort of install them in their garage, like the image on the bottom side there. I've looked here at Quebec, so the blue line being that suburban household, one bounding case, it would only require me to drive about 50 kilometers per day. Versus if I were to rely on level 2 public charging, which is a little bit faster than plugging into your wall, I'd have to drive about 75 kilometers per day versus, and this is a bit of an unrealistic scenario, but I'm putting it there just for sake of comparison. If I were to rely only on level 3 public charging, which is sort of that really big plug that it only takes about 20 minutes to charge up your car, and also costs more money to do it, that would require me to drive over 250 kilometers per day. So I've sort of set these up as bounding scenarios because the reality is that someone that's relying on public charging infrastructure, they're probably doing a bit of a mix between level 2 and level 3. So the reality is probably somewhere between 75 to 250, but it does sort of show that variation. And also the fact that people that rely on public charging infrastructure are definitely paying a bit more and would, of course, have to drive a bit more if they wanted to make their vehicle equal in value to a gasoline one. And then sort of the last result here, this is sort of looking out into the future. What happens in 2030? So in 2030, let's say that the purchase subsidies that we have on EVs, they sort of run dry. The provinces don't renew them. And then the federal government also doesn't renew that one as well. And then the carbon tax is ratcheted up to its final configuration, which is $170 per ton of CO2. And this applies, by the way, not just to gasoline, but also to electricity. And then lastly, on the technology front, let's say that the cost of batteries declines because of economies of scale, because of advances in manufacturing, tech breakthroughs, all that. Let's say the cost declines by about 50%. The cost of batteries being the most expensive component of EVs. So what happens then? So here I ran a scenario which compares the province of BC to Alberta. And the result that I found, so again, we're looking at the intercept, right, on the x-axis. The result that I found is that it's not really very different. Right? So what this is kind of saying to me is that carbon tax is actually playing a key role when the subsidies kind of run dry. And then, of course, couple that with technological advances, that there's not really too much difference compared to the present day scenario versus 2030. And so it really does kind of indicate the critical importance that the carbon tax could play in driving the adoption of electric vehicles towards the typical consumer. So I'll lastly conclude with a slide here on policy implications, just to kind of summarize some of the things that I've mentioned in the talk here. So number one, incentivizing smaller EVs, or the opposite, disincentivizing larger ones could reduce total cost for consumers. This makes it cheaper for consumers and much more attractive to be able to do that. Of course, this would require shifting sort of the maximum prices that rebates are available, or some other sorts of configurations on policies. But this is definitely one way that we could see a drop in costs. Secondly, high public charging costs could be faced by households that live in shared dwellings or ones that basically don't have access to electrical upgrades. These sorts of households will require some sort of additional policy measures. Perhaps at the municipal level, this is generally where it sort of makes the most sense to kind of offset some of that additional cost that is faced by these types of households. Thirdly, incentivizing super users. I didn't touch on this, but this is sort of a thread that runs through the whole thing. You saw that in some cases, the amount that needs to be driven is way out there, right, in terms of how much you need to drive daily. There's a class of users that are already doing that, and that's the super users. Things like Uber, things like taxis, logistics, other businesses are already driving that. So incentivizing electric vehicles into that niche is a really good way that policymakers could capture the emissions reduction potential of electric vehicles. And then lastly, sort of capturing the note from the last slide, in the 2030 scenario, in the absence of purchase subsidies, carbon tax it could be a key to increasing the adoption of EVs. The counterpoint to this is not to say that, you know, we need to tax our way to adoption, but it does sort of show how critical the carbon tax could be as a lever towards shifting some of the economics of vehicles for the everyday Canadian. Lastly, just a note of acknowledgements. I'd like to thank Professor Amanda Jang and Milan Panlikar for all of the kind support intellectually and morally over the past few years. So thank you so much, and I'll stop there. Yeah, yes.
I did mention that there's like including the cost of I know you mentioned like taxis, Uber. I was wondering, you went about like the literal studies or pilots done on like broader public transportation.
Yeah, sure. Like in terms of this similar sort of analysis. Yeah, I mean, we didn't run a scenario with public transportation, but I would imagine that the economics for that would be a little bit different, because here we're looking at sort of like a single consumer. And so it is possible to kind of do it for public transportation, but it would kind of have to take into account that, you know, it's like the number of passengers per bus and all of those sorts of things. So it is definitely possible. That's sort of quantitatively, but qualitatively, I can speak to electric buses. They're an excellent way to capture the emissions reduction potential of basically electric vehicles. It's a segment that is starting to emerge in the Canadian context. In places like China, which is where some of my other research is focused on, electric buses are sort of everywhere in some of the mega cities. And so, you know, the emissions reduction potential from those is really fantastic. Yeah. Yes.
So you mentioned like super users, like, you know, how important it is to get super users adopting. Are they adopting electric vehicles? I sort of feel like it's like in my head, I feel like people who drive less, or people I know who bought electric cars, or like people who drive more. I think my mom right now drives a ton, and she's like, oh, I can't buy one. You know what I mean?
Mm-hmm. Yeah, for sure. So the question for Zoom is are there actually super users that are adopting electric vehicles? So yeah, I guess maybe a couple of reactions to that. I mean, firstly, you know, just to go back to the initial comment about electric vehicles are still kind of within the realm of early adopters. So it's people that are basically purchasing it as sort of a lifestyle choice. It's still sort of within that, although it has been changing over the past few years because the economics kind of makes sense. I personally bought an electric vehicle about 5 years ago because it made sense for me, and I did the numbers in an Excel sheet, and it was cheaper for me. And I'm certainly not a wealthy consumer, so it made sense for me in my particular circumstances. But in terms of like incentivizing it for super users, there is a little bit of that happening at the fleet level, and so for example, it's happening a little bit more so at the provincial level, especially in BC. So for example, there's the BC Go Electric Fleets program, which is part of one of my other studies. They're actually incentivizing vehicles to go into fleets because fleets are using these vehicles a lot more, right? They're driving every day like 150, 200 kilometers and those sorts of things. And so it immediately kind of makes sense for them to be able to switch to electric. But the challenge in going into those sorts of markets is that there's a whole other set of operational issues that come up, right? You know, can I use an electric vehicle for the exact same stuff that I use a gasoline car for, right? Can it tow the amount of stuff that I'm towing, or, you know, can it do all of the other things that my business or my operation needs? So there's a whole other set of like qualitative type barriers that come into play that are sort of preventing some of those things. But the other sort of place that this is happening slowly is within ride hailing. So, you know, where public policy can kind of bridge some of this gap is actually requiring some of the ride hailing companies to actually go electric. This is happening outside of Canada. So, you know, like say, for example, Uber, your Uber fleet has to be electric, for example. That's a really, really good way of capturing emissions reductions. Yes.
Thanks so much for sharing.
Yeah.
I guess I'm wondering about the framing of the research and function in general. Like, do you think that middle adopters are cost limited? Is that the thing that is preventing them from adopting? Like, obviously, the early adopters are, just willing to ignore the fact that maybe there isn't a cost to it and upbeat values it. So
Yeah.
I don't know.
Yeah.
If you think that.
Yeah, absolutely. So the question is are typical households just limited by costs, or are there other factors that are limiting them as well? Absolutely the latter. Cost is a big part of it, but there's definitely other factors as well. As I mentioned, just things like accessing public charging infrastructure and the ease with which you can actually charge your car. So I mean, for example, the last time I was on campus, which was about a year ago, and I drove my car here, I actually had a really hard time finding a charging station. But today when I drove in, it was all seamlessly integrated where I could pay for my parking and my charging at the same time. So things like that are slowly happening that are making it really easy for like the average consumer to be able to use it. But however, there are still a lot of barriers. Charging is one of them. Another one is sort of the ability to actually install electrical upgrades at home. Right. So this is sort of why I set up that archetype of an urban household, the ones that actually have this difficulty, because really the way to optimize your EV usage is to actually have at least a level 2 charger at home, which is just a little bit faster than a wall plug, or I should say about 6 times faster than a wall plug. But a lot of people can't do that, right? Just because they're limited by the circumstances that they live in. And that has to do with things like the fact of where they live. As I mentioned, like say you're living in a Vancouver strata, it might just be really hard to upgrade the electrical infrastructure over there. So there's all sorts of like very qualitative barriers that come up. Temperature is another one, for example, right? Cold weather requires us to heat a lot more. And so in the Canadian context, which I did study, I didn't focus on in this talk, but the impact that temperature has, if you're using your heating a lot, it does drain your battery a lot faster. It doesn't necessarily impact the costs, which is hidden here, but it does qualitatively impact how much you're using it on a regular basis. Yeah, I think I'm out of time. Thank you.